Okay, so question 3 asks us when is it appropriate to use the normal approximation for the sampling proportion p hat. So we have 4 different choices here, and the rule that we usually use is this is okay, or the normal approximation is okay, when n times p hat is bigger than or equal to 15 and n times 1 minus p hat is bigger than or equal to 15. We need both of these to be true. So in each of these 4 cases, I'm going to solve for n times p hat and n times 1 minus p hat. Okay, and I need my answers to be greater than or equal to 15. Okay, so in this first case, n equals 100, p hat is 0.1. Multiply them together, I get a 10. Okay, the second case, when n is 400 and p is 0.99, if I multiply them together, I get a 396. Okay, in the third case, when n is 100 and p hat is 0.9, I have a 90. And the last one, when n is 60 and p hat is 0.3, multiply them together, I get an 18. Okay, so I see one of these 4 already gives me a problem, since I need both n times p hat and n times 1 minus p hat bigger than 15. And the first one violates that already, so I know the first one is definitely not the answer. Okay, so now I have to do n times 1 minus p hat to see which of these 3 cases works. Okay, so for the 400 and 0.991, 400 times 1 minus p hat is 400 times 0.01. If I multiply those together, I get 4. Okay, the second remaining case, I do 100 times 1 minus 0.9, or 0.1, okay, which is 10. And the third remaining option is 60 times 1 minus p hat is 0.7. And 60 times 0.7 is 42. Okay, so of these remaining 3 options, 4 is not bigger than or equal to 15. Okay, so 400 with p hat is 0.99 is out. 10 is not bigger than or equal to 15. Okay, so 100 and 0.9 is out. But 42 and 18 are both bigger than or equal to 15. So the answer would be the 4th choice, n equals 60 and p hat equals 0.3.